Let's look at rotary compressors. A rotary compressor uses a rolling piston with a cylindrical housing to compress refrigerant vapor against a reciprocating vane. The spring above the vane holds it in contact with the rolling piston at all times, providing a vapor-tight seal between the high and low pressure zones within the compressor. There is only one valve, the discharge valve. It takes 2 full rotations of the shaft to draw in and compress a volume of refrigerant vapor. Notice how compression and suction occur simultaneously on opposite sides of the rolling piston. For example, starting at top dead center, as the eccentric shaft rotates the rolling piston past the suction port begins to open, forming a space between the vane, the rolling piston, and the housing. With continued rotation, the volume of this space increases, reducing the pressure below the low side pressure of the cycle. Refrigerant vapor is drawn in through the suction port for a full rotation until the compression volume is filled with suction vapor at low pressure. In the next rotation, the rolling piston blocks the suction port. Low pressure vapor is compressed in the decreasing space between the rolling piston, housing, vane, and discharge valve on the other side of the piston. Initially, the discharge valve is closed, trapping the low pressure vapor. Continued rotation of the rolling piston along the inside of the housing reduces the volume of the vapor, compresses it against the vane, and raises its pressure. When vapor pressure exceeds the high side pressure, it pushes the discharge valve open. Discharge continues until the rolling piston completes the full revolution and has expelled most of the high pressure vapor. The discharge valve closes when the rolling piston reaches top dead center. Then the cycle is ready to begin again. This is the mechanical positive displacement vapor compression cycle using a rotary compressor.